This video is about solving equations that fall within these two special cases that we have. These special cases are: one, identity, in which case there are infinitely many solutions, and two, contradiction, for which there is no solution. Now recall that most equations have solutions. 2x minus 3 equals 5 is a two-step linear equation. I draw a line at the equal sign, and now I'm going to make a 0 where the 3 is by adding 3 to both sides. Remember, we have one rule: do the same thing to both sides when solving. 5 plus 3 is 8. 2x equals 8. 2 is being multiplied by x, so I need to make a 1 in front of the x instead. So I divide both sides by 2, and I get 1x equals 8 divided by 2, which is 4. Now this is not a special case. This is an equation that has one specific solution, meaning only the number 4 works when you plug it in to the original equation. So 2 times 4 minus 3, does that equal 5? Well, 2 times 4 is 8, minus 3 equals 5, and that checks out. So that's normally, most often, what's going to happen when you're solving an equation. All right, now let's look at example 1. This is a special case. The equation we're given is 2x minus 3 equals 2 times the quantity x plus 1. Now, the way I teach this, I encourage you to do all simplification first. Because I have parentheses on the right, I know there's something I can do to make that side simpler. The 2x minus 3 side is already simplified. 2 times x is 2x. 2 times positive 1 is positive 2. On the right, the parentheses are gone. Now notice we've gotten down to 2 terms on each side. And for linear equations of one variable, this pretty much indicates that you're ready to start solving. So I'm going to draw a line at my equals. I need to get all my variables on the same side. So I want the 2x on the right to be gone. So I'm making a 0. Now the reason I'm doing that is because 2x minus 2x is 0, which leaves the positive 2 by itself. Now on this side, 2x minus 2x is 0 on this side as well. And so what I get is negative 3 equals 2. There's no x. Let's use red. No x. So the x has disappeared, and what's left behind is an absolutely false statement. Negative 3 does not equal negative 2. It doesn't matter what x is. Negative 3 equals 2 is a contradiction. So this is called a contradiction. Because it's false all the time. And so this is a situation where the equation we started with was bad from the get-go, and so we say that there is no solution to this equation. All right, another example. 3x minus 6 plus 2x equals 4 plus 5 times the quantity x minus 3. Well, we definitely need some simplification. On the left side, we have like terms, 3x plus 2x. On the right side, we have parentheses. So the first thing we're going to do is simplify our sides. 3x plus 2x is 5x. Recopy the minus 6. Recopy the equals, recopy the 4, and then distribute the 5. 5 times x is positive 5x. 5 times negative 3 is negative 15, and the parentheses are gone. Now the left side is simplified, but the right side is not, because I have noticed I have 3 terms, 1, 2, 3. To simplify it, I need to notice that 4 and negative 15 are like terms. So I'm going to recopy the left side. Then I'm going to do 4 minus 15, which is negative 11. Then I recopy the plus 5x. Now notice I have 2 terms on each side. I have x's on both sides. So I am going to start by getting rid of the x on the right. And I do that using subtraction, because 5x minus 5x is 0. Leaving negative 11 on the right. 5x minus 5x, 0 on the left as well, bringing down that negative 6. So again, my x's have disappeared from the problem, leaving behind a false statement. This is false. Negative 6 does not equal negative 11. So again, we have a contradiction. And that means we have no solution at all. The equation, again, was bad from the start. Next example. 2x plus 8 equals 2 times the quantity x plus 3 plus 2. All right, well, this side is simple. This side, however, has parentheses indicating the need for simplification. I'm going to recopy the 2x plus 8. I'm going to recopy the equals, and then I'm going to distribute the 2. 2 times x is 2x. 2 times 3 is positive 6. Recopy the plus 2. Now I still have simplifying to do on the right-hand side. And I see that I have a 6 and a 2, which are like terms because they're both constants, and 6 plus 2 is 8. So I get 2x plus 8 equals, recopy the 2x, add the 6 and 2, and get 8. Now stop and read that equation. 2x plus 8 equals 2x plus 8. They're identical. The two sides are identical. This is a situation where we're solving what's known as an identity. An identity is something that's true all the time. So a contradiction was false all the time. An identity is true all the time. 2x plus 8 equals 2x plus 8. Duh, that's like saying the cat is a cat, or the dog is a dog, or the toaster is a toaster. Now I do want you, just in case you don't notice that the two sides are identical, I want you to see what happens when we solve it. Now I have x's on both sides, so I'm going to move the x from the right by subtracting. And that works because 2x minus 2x is 0, leaving the 8. 2x minus 2x here is also 0, leaving just an 8. Now notice 8 equals 8. Duh. It's always true. 8 does equal 8. It does. It doesn't tell us anything about x, though. The x's have disappeared. Let's write that down. X is gone. And we're left with something that's true. So again, we got something that's true all the time. X always equals 8. So the solution is all real numbers. Or, if you prefer, and most students do, and teachers too, because it's faster, you can just write this big R with like this double vertical back. That's a pretty classic printed symbol for the real number system. So the solution is all real numbers. All right, let's see, do I have another example? I do. Okay. This equation is 3x minus 7 3x minus 4 minus 7x equals 2x minus 4 minus 6x. Now again, I have some simplification that needs to be done, and I recognize that because I have more than 2 terms. There's 3 there, there's 3 there, so that should make you very suspicious that you have like terms. And we do. 3x minus 7x is negative 4x. Recopy the minus 4. Then we have 2x minus 6x, which is negative 4x. Recopy the minus 4, and stop and look at the equation. It says negative 4x minus 4 equals negative 4x minus 4. Duh. They're identical. Of course they're equal. Identical. So this is called an identity, and the solution is all real numbers. Or that big R with the double back. Okay, so our 2 special cases are when the x drops out. In one case, the x drops out and you're left with something that's true all the time. That's an identity and has all real numbers for the solution. If the x's drop out and then you're left with something that's just false, like 2 equals 17, that's a contradiction, and the solution will be no solution. Thank you for watching.